I'm going to do a bit of work on power today. So power is the rate of doing work. And we know that to find the work done, it's force times distance. So, for example, a truck is pulled up a slope. At speed 8 meters per second by a force of 2,000 newtons. So the work done per second by this force so in 1 second it will move 8 meters because it's travelling at 8 meters per second. So it's going to be force 2,000 times distance, which gives us 16,000 joules. So here, these joules is Newton meters. So force times distance. This just translates directly to power actually, because power is the rate of doing work. So if the work done per second is 16,000 joules, the power is 16,000 watts. So that 1 watt is 1 joule per second. And if you think about units now, we've got work done per second, which takes us to there. And so power, and this is another one where we seem to have the same letters for lots of different things. So power is equal to FV. So we've got this force, this driving force, and meters per second is velocity. So force times velocity. So you can see that coming to there from the units, where F is the driving force. And V is the speed. Sorry, I think I just said velocity, but V is speed, not velocity. So we have power as a scalar thing. Sometimes, just to make this even more confusing, in questions they call this driving force T, which is a tractive force. I might well use D. Otherwise I just find it gets really confusing. If you're doing physics and you're used to using, different letters in there, just go with whatever feels right. You're not going to get, marked down for using different letters. So power equals driving force times speed. So looking at a different example, let's switch that slide up. So a van of mass 1,250 kilograms is travelling along a horizontal road. The van's engine is working at 24 kilowatts, so that's 24,000 watts, and there is a constant resistance to motion of 600 newtons. And the first thing we want to do is calculate the acceleration when travelling at 6 meters per second. Sorry, it's smudgy. So we can use power equals FV. And we know the power is 24,000. And that's equal to F. You call that D for driving force, or T for tractive force if you want to, times 6. And so F is equal to 4,000 newtons. So we've got the truck. I'm not used to drawing trucks, they're normally cars, something like that. And we now know that we've got a driving force of 4,000 newtons and this resistive force of 600 newtons. And so to find the acceleration, we can use F equals ma. So resultant force equals mass times acceleration. Yeah. So I'd almost be tempted to put a different letter in there, like capital D for driving force, because it just gets so confusing. Yeah. I'll make up my own letters one day for this. Yeah. So anyway, 4,000 with direction of motion minus 600 is equal to the mass times the acceleration. And that gives the acceleration as being 2.72 meters per second squared. And then we want to find the maximum speed of the van. So the maximum speed, if you're travelling at maximum speed, then the forces are in equilibrium. And if the forces are in equilibrium, then this driving force, F, is equal to 600 newtons. And so the power which is 24,000 is equal to 600 . . 600 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . times v. So it's still working at the same rate, but because this force is lower, it makes the velocity higher, and this gives you v as being 40 meters per second. So you could convert that into miles per hour if you wanted to. I think it comes out about 90 miles per hour if you did a quick conversion on that. You can times by 2.25, that works quite well. So to start with, if you do in your FM1 online books, and it's page 32, question 1 to question 8. So they're all a little bit like that, just to get that principle just to really sink in before we move on to slightly more complicated questions.